All right, resolving the vector.
So that sounds like a judgment.
Well, I guess, kind of. Basically, we have kind of a formula here that a vector, if we know the direction angle and how long it is, then we can find the component form. Because think about it, a vector...
I like this already.
A vector is simply a line in a certain direction, so that has an angle.
And we're going to measure our angle just like we have with all of our trig angles to this point in time.
Right, and then if we know how long this line is, which is the magnitude of our vector, we
let's
can
say
talk about like a...
Okay, let's just say that the line is 5.
Okay. So, what, the angle could be like 45?
Oh, okay. Sounds great.
We can plug it in, and we can actually find the component for it.
Shut the front door.
No, I won't. That's really the way it works. Okay? Okay, so let's do example 5
Okay, let's do it.
So we just need to plug this in for theta and this in for our magnitude of V.
All right.
And so, what am I doing?
I don't know what you're doing.
6. Cosine comes first, just like on your
115.
unit circle by the BT dubs, right?
BT dubs.
BT dubs.
I like it.
It means by the way.
Thank you. Okay, so we need a calculator because I don't know what the cosine of 115 is.
Do we not? Has that
Wait,
not
that's
one of
not
the?
one on the
is that
unit
not on the
circle.
circle? Okay, I'm on it right
So
now.
make sure your calculator's in degree mode.
Yep, degree mode.
6 times cosine 115.
Okay,
Just put
cosine
that in
115.
right at the same time. There will be decimal since it's not on the unit circle. We'll just have to live with that.
Oh no.
Hey, by the way, I'm gonna write the code word.
Code word.
The code word for this video is right here. So if you listen with the sound off, look, I'm writing. If you listen with the sound on, I'm telling you, look at the code word. It's right here. That's the code word.
So I get 6 cosine 115 degrees to be negative 2.536.
Final answer?
Final answer.
Okay, and then 6
Phoning a
sine
friend.
115.
So let's just put a little sine action here. That's a little sin. 5.437. 5.438. Let's have correct rounding.
Okay, so this is the component form of that vector.
Now think about this. You can rough sketch this out and get like a general idea of where you should be.
Like 115 degrees is 25 past 90, so that's the second quadrant.
Do our coordinates match second quadrant stuff? That's
Left
the big one.
2.5, up 5.4.
I mean, does that sort of make sense?
That does make sense.
Okay.
Okay. We at least have the correct sign. So
that's right.
The opposite side of this now is finding the magnitude and direction of vectors given their component form. I feel like this is a negative.
That should be a -3 there.
Okay.
Yeah.
All we do is we need to think of this like, oh, that's a terrible scale. Hang on. Like this is a triangle. 3, 11 is this really tall vector.
Right.
3, 11. Those are our components.
Oh my! Hold on. I feel like you're setting up a right triangle.
That's exactly what I did.
Son of a jeez.
So we would Pythagorean theorem. Maybe you should tell them to put the test.
Right, but it'll make noise.
That's true. So square root of 130. The magnitude is square root of 130. To find the angle, though, this is the thing we need to make sure we know, is that we would inverse tangent y over x. So 11 over 3.
Right.
And so in the first quadrant, it just gives you the answer. In some of the other ones, we're going to have to watch out. First
right,
one,
and you want to make sure you're in degree mode again because, you know, could be sketchy if you're not. So that's going to be 11 divided by 3. That's not right. I got it in radians. So hold on one second. I'm going to do a quick conversion. 74.745 degrees, which that looks like it should be ish.
Okay, that's what our calculator gave us, and in the first quadrant, that's really our answer. But if we look at some of these other situations we've got going on, like put an inverse tangent of
inverse
-4
tan
thirds.
of -4 thirds times 180 divided by pi. -53.130. Yikes.
Okay, what it's doing is it's giving us this reference angle, so we have to do 180 minus 53.130.
Which would be 126.87.
Okay, and then we would go around in the same sort of way, like this one should be telling us this angle, so we're going to have to do 180 plus on this angle.
So that, what is that, 2/15? So 7.594.
So 180 plus 7.594, which is 187.594.
Oh, psh, I was getting ready to punch that in, and
So inverse tangent negative 2/7.
So inverse tan.
This one should be 360
negative
minus
2/7.
the angle.
360 minus.
Yeah, after you convert.
So negative 15.945.
So 344.055 minus 15.945. Okay, so think through, just remember your calculator tells you the reference angle, and then
right.
You have to do work to actually figure out what that angle is.
Perfect.
Oh. Now, one of the great things about vectors is that they have very real applications in the real world. You use them to represent things that also have magnitude and direction, like velocity, which is speed going a certain direction, or you use it when you're talking about forces in physics. It's very applicable, and if you've had physics, you know this. Like, vectors are a really big part of physics, so that's kind of real world application. So we're going to do word problems that are related to vectors and forces and speeds and things like that. And so I just thought I'd throw out some steps here to kind of help you, because sometimes they can seem a little daunting when you first approach them, but actually they all work out pretty much the same way. So one thing is, they tend to, in a problem, they'll tell you what like the speed and the direction of something is. Like an airplane is flying at 400 miles per hour with a bearing of some angle. Okay, so one of the first things you want to do is whatever they give you, if it's not in component form, and it probably won't be, convert it using that formula we talked about. Then if you have vectors in component form, what you're allowed to do is you're allowed to add or subtract them depending on what the problem asks you, because usually that's what it's asking us to do, is either add or subtract them to get some kind of a result. And here's like 3 situations that we've got. A, you could have 2 forces acting on an object, and so adding those forces together gives you the resulting force. So like if you're dragging a box with a friend, you've both got like a rope or something, and so one of you is dragging this way with a certain force, the other is dragging this way with a certain force, and so we could add those forces together, because that's a concept you learn in physics, and hopefully you've heard before that your forces, like every force has an equal and opposite reaction and all that stuff, so that if we're both pulling in these 2 directions, those forces are going to add together and contribute to a general pull this other way, right? So that's one thing we could see. We could see, I put a transportation device here because it could be an airplane, it could be a boat, it could be a car.
I can't believe you started without me.
Calm down, let's just keep going. Catch your breath. Okay. So it could be moving at a certain velocity and current, like a wind current or a water current, depending on if you're talking about a plane or a boat or whatever.
Hopefully not a plane acting like a boat.
That could be a tricky situation. So if they give you information about an airplane, for instance, and then they tell you about the wind acting on it, you add those together, and that tells you what's actually going to be happening.
That's right, every time.
And then sometimes they'll try to trick you. The third thing I have listed here is they'll actually tell you like that it's trying to move a certain velocity or force, but then there's some other thing acting on it. And so in that case, like if they give you what it's actually doing, then we're going to have to subtract to get what it's trying to do.
Subtract, I don't know. That sounds tricky.
And then the last step you do is you'll end up with a component form of a vector whenever you add or subtract 2 vectors together. So you have to change it back. It's liable to be
a pretty wacky number.
It could be, yeah, decimally and all that stuff. And so you convert back to direction, angle, and magnitude, like what we did in example 6, which is just rewind a little bit if you don't remember what it was like. So that's just some general steps, because they can seem a little tough. Let's try one.
Yeah.
Yeah, right
Okay.
now? You
Yeah,
ready now?
let's do it.
Bam.
Wow.
Example
Look at that.
7.
That looks like a paper airplane there.
It does, because that's what a DC-10 jet is, right?
I mean, I was on one of those this summer. You and I were on one of those this summer.
Were we really?
Paper airplane.
It was not an airplane.
Is it?
What? Okay.
Okay.
A DC-10
Fine
jet.
at a bearing. It's got a bearing of 65
Bearing
degrees.
is 65 degrees. So it is helpful for us to remind ourselves what bearings are from north, and you go clockwise. That's how we measure bearings. So this angle right here, we're saying is 65 degrees.
Right. North being 0, south being 180.
Right.
Mm-hmm.
And it goes in the other direction than what we're used to.
Right.
So, and this vector is traveling at, well, 500. The vector is 500 miles per hour. And that speed corresponds actually to the length of the vector.
Right. This is
the magnitude.
Oh, I wanted to say that.
Well, we'll say it.
The 500 is the magnitude.
Okay, and the 65 degrees is
the bearing.
The
but I didn't want to say
direction,
that part.
direction.
I wanted to say
magnitude
the magnitude
and direction.
Yeah.
Okay.
Okay.
So it wants us to find the component form of the velocity of the airplane. And then it tells us about the whole bearing thing. So in order for us to do that, we have that formula where
magnitude, cosine alpha. Son of a
Alpha?
gun. Theta, whatever. Look, we have a 65 situation.
But is that what we're going to plug in?
Oh, no.
Because that's
Trickeration
not
is-
a trig angle, that's a bearing. So what we need is, what is this angle?
15.
What?
25. I'll get there eventually.
If you do 90 minus 65, you get that this angle is 25. That's the theta we need to plug in here because our calculator tells us trig angles. So 500 miles per hour times cosine of 25 degrees, comma, 500 sine 25. Remember that cosine on our unit circle had to do with our x's and sine had to do with our y's. Same thing is going on here. That's why cosine's in the x coordinate of our vector and the sine is in the y coordinate of our vector. I got
some answers.
Okay.
For cosine, 453.154.
Okay.
And for sine, 211.309.
And something interesting that this is actually telling us, this is what the answer is, but it actually, when we put it in component form, it breaks up what's going on into two separate velocities. Like the airplane is actually traveling east at 453.14 miles per hour at the same time that it's traveling north at 211.309.
That's just
miles
as
per
crazy
hour.
talk right there.
Well, it's also true talk, but it can be crazy and true. Okay, so that's what's going on there.
Is it on Wikipedia that way?
Form. I don't know.
I mean,
Do you believe Wikipedia over me?
sometimes. Hey there, another vector example.
Yeah, example 8. Pilot Megan McCarty's flight plan has her leaving San Francisco International Airport and flying a Boeing 727 due east.
Now, I believe we were on a Boeing 727 this summer going to ISTE.
I thought you said that we were on a DC-10.
I forget.
Just a moment ago.
Okay.
Okay, there is due east, by the way. We all know what due east looks like.
90 degrees.
A bearing of 90 degrees.
Excuse me, a bearing of 90 degrees.
An actual angle of 0 degrees.
Zero, yes,
okay.
right there.
There is a 65 mile per hour wind. That's a pretty hefty wind.
That's big.
With
That's
a
big
bearing
wind.
of 60 degrees.
Whoosh.
So this is our wind vector. Had him drawn. Excuse me, I had him drawn, but I didn't have him labeled. Okay. Find the compass heading that she should follow and determine what the airplane's ground speed will be, assuming that its speed with no wind is 450 miles per hour. So she is supposed to be flying due east.
But if the wind is blowing
this way,
she's got to have to like.
She
tilt
actually
the
has
plane.
to go this way, in order to actually, when the wind hits her, the wind is going to move her, so that she's actually going due east. So we need to figure out what this angle is to get around to purple. They tell us the
wind is 65 miles an hour.
Wind is 65 miles per hour, and they tell us that the plane speed with no wind is 450.
Now,
so that's
we've got magnitude and direction for one of these. Oh yeah.
Yeah, for one of them, for the wind.
The wind, the magnitude is 65, and the direction is 30.
Right, because this is 60 degrees,
Yes.
so that makes this 30. So we can find the component form for the wind.
The vector.
Do you want to work on that?
Yeah, I'm on it.
This is for the wind. The wind plus what the airplane is trying to go. Okay, and we know some of what's going on with the airplane. We know it can go 450. But one of the things we're trying to find is that angle that it needs, the bearing that she needs to head out on, right? And if we add those together, we get the actual vector that's happening, which we know some of the information for. We don't know the speed in this case, so I'll just put an X there, but we do know that it's going at 0 degrees. Now, correct me if I'm wrong, but it looks like we've got like some equations going on here.
I feel like there's no correction needed because once again you've shown your genius. So for the wind, I've got us a vector of 56.292 and 32.5.
Okay. And so we have to think about this. If this is what the wind is, well, 56.292, which is the X value for our wind, plus the X value for the
airplane.
The airplane, yeah. What it's trying to go, 450 cosine theta, that has to add up to be what the airplane is actually doing. Okay, and same thing for the other one. So 32.5 plus, that's not supposed to be a comma, 450 sine theta.
Your handwriting is so good.
Thank
I
you.
can't write that good on that thing.
Well, X sine 0 degrees. I pride myself on excellent penmanship.
As well you should.
Okay, so now this could look worrisome, except for if you're thinking about it, cosine of 0 degrees or sine of 0 degrees, one of those is 0.
And the other one is 1.
So that's super helpful. Which one is 0?
Sine.
Sine of 0 is 0. So what that does is that makes it x times 0, which is still just 0. Okay, this is going to turn into 1, which means that it'll be 1x. And so we should be able to solve this one for theta.
There's only one variable on the bottom.
Okay, now think about, oh wait, well, never mind. Okay, so we have 0 over here. We need to subtract 32.5
right.
and divide by 450. I was like, why don't you get started? But
Arc sine of, I just needed a little slight skosh. 32.5 divided by 450. I'm going to arc sine
You're going to arc sine it.
I'm going to arc sine it.
So theta is the inverse sine or arc sine of negative 32.5 over 450. If we did too many steps at once there for you, just go back and think through, if this is an equation, how do I solve that for sine theta? And then since you have sine theta by itself, you have to inverse sine.
I got negative 4.142. That could work.
That could work. Because it's going due east, and the wind isn't going to affect it a ton.
Yeah, not a ton.
Okay, so
I feel like that's a pretty good. That's that angle.
That's what that angle is. But we actually want the bearing to get around to there.
Oh, so add 90.
So 90 plus a positive 4.142. Okay, that should be the bearing.
I think that's a good bearing. I feel comfortable. Like, that makes sense.
142 degrees.
If we had gotten something that was, way down fourth quadrant, like
that would, yeah.
Then use your brain. Like,
yeah, if you're going 450 miles per hour one direction and then something is hitting you for only 65, it's not going to affect you as much as you might think.
Right.
So we need to, although in a car where you're going 70 and the wind is going 70, now that's different.
That's different, yes.
That can really do a number on you. We also need to figure out what the X was here. Okay, so...
Well, if we've got our angle is negative...
So what we can do is we can plug it into this other equation, right?
Yeah, because theta's got to be the same on everything.
Right, so I'm going to move this up here, 56.292 plus 450 cosine 94.142 equals x. So we just have to plug in the left side and get what it is.
503.777. Roger.
And that's miles per hour.
Over.
So what this problem is saying is that the flight plan says
go straight east.
Right. The wind is going 65 miles per hour at a bearing of 60 degrees, which is going to cause the airplane itself to have to adjust
while it's flying
angle so that it's going a bearing of 94.142 so that it corrects it to get to 90 degrees. But also because of the way the wind isn't going straight with the airplane,
right,
but it is contributing. So instead of going 450, it's actually going to go faster. If you've ever been on an airplane and it always seems like the pilot gets on and then it's like, hey, we made great time, so we're going to be landing 20 minutes earlier. You know, it's because of the wind, right?
With the wind blowing behind you.
The wind blowing behind you. So, I mean, it could be because of that.
Yeah. I mean, it may be the pilot was just goosing that sucker.
Yeah. Could be. Could be. But that one was pretty tricky. Most of them that you actually have to do in the book aren't quite that bad. Like that was. But
the process is.
It's a similar process. Component form is your friend.
Yes.
Because that helps you add vectors together.
I agree.
Happy 6.1.